Dear students, in this video we are going to see the experiment number 3 regression analysis for the course 20 CS 2032 Machine Learning Techniques Lab. Regression analysis comes under the category of the supervised machine learning algorithm. Supervised machine learning algorithm means the machine will learn from the labeled data. The regression represents estimating the relationship between a dependent variable with the one or more independent variable. The dependent variable is called as a target variable and the independent variables are your input variables. When we predict the regression or when we predict the outcome can be either a numerical value or it can be a categorical value. So the prediction output is a numerical value, means it is called as regression. When we predict the outcome, which is a categorical, which is called as a classification problem. So here we are going to see about 3 different algorithms, that is the single linear regression, multiple linear regression, which is mainly used to predict the numerical values, and the last one is the classification by using the logistic regression, where we are trying to predict the categorical value. That is predicting the numerical value, what it represents. We have a value x, we have a value y. So I have an input of age. So age of a house. So based on the age of the house, we are trying to predict the price of the house. The predicted value is a numerical value. So if you try to predict a price based on only a single input, which is called as single linear regression. So why it is called as linear regression? The relationship between the x and y forms a linear line which will be represented by y is equal to a0 plus a1x. So x is an input and y is an output. a0 and a1 are the regression coefficients. And when we try to predict the price output based on more than one inputs, so age of the house and square feet of the house and the location of the house, multiple input categories or input variables predict the output value, then it is called as multiple linear regression. So this will be represented by y is equal to a0 plus a1x1 plus a2x2 up to an xn. So what does mean by classification? So we have the values like length and width, some information. So based on that we want to predict the species type. The species can be either a cat or a dog. So based on the some properties we are trying to predict the category of the output, then this type of problem is called as the classification problem. Now we will move to the simple linear regression. The simple linear regression is represented with y is equal to a plus b plus x. So this is the input given to us, x, and the corresponding y. So based on the x, we have to calculate the x bar value, and based on the y, we have to calculate the y bar value. So this equation we can write as y bar is equal to a plus b into x bar. The a represents, so instead of a only, we have here as b0 and b1x. And here the b1 represents the slope of the line. To calculate the slope of the line, we have an equation x minus x bar into y minus y bar divided by sigma x minus x bar the whole square. So x we have, y we have, we need to calculate the x bar and y bar. Based on that, every x value we have to calculate x minus x bar. Then we need to calculate y minus y bar, and then calculate x minus x bar the whole square, and also we have to calculate x minus x bar into y minus y bar. After calculating the summation of this thing and the summation of this thing, we substitute in the formula of B1, we will have the slope value. So based on the slope value, so once we get the slope value, that is the B0 plus B1 x. So we calculated the B1, now we have to compute the B0 value. After computing B1, we need to calculate the B0. B0 represents the intercept. So we have x bar, we have y bar and we have B1. So we have an equation y bar is equal to B0 plus B1 x bar. So from that we need to compute the B0. So B0 is equal to y bar minus B1 x bar. So based on this, we need to calculate the B0 value. So we can able to form the regression line for the given x and y. We computed the regression line y is equal to B0 plus B1 x. So during the testing process, when we give the values of x, it try to predict what is the corresponding y value. So when I give the x during the testing process, the predicted value of x is this thing. So this is my predicted value for the particular x, and this is the corresponding y value of the x. This is the actual y value and this is the predicted y value. So all the orange color represent the actual value of y and the blue color represents predicted value of the y. So the line represents your regression line. If we give the test value of x, it try to predict the y value, but the actual value for that x is, the corresponding y is here in the orange value. So the difference between the actual and the predicted will give the error. So error represent y predicted minus y actual. So this error should be always minimum. So we formulate a regression line. So that makes the predicted value and the actual value difference should be minimum. So by computing these, we have to analyze the performance of our regression algorithm. These are the various performance metrics which will help you to find whether the regression algorithm we developed is how it is performing to the input data. So y represent the actual value and y bar represent the predicted value. So we need to find out the difference between the actual and the predicted. Based on that, we will calculate sum of squared error, root mean square error and R square error. We expect all these should be minimum so that our regression algorithm will perform good. So now moving to the multiple linear regression. So in case of multiple linear regression, the y value is predicted based on two x input x1 and x2. So we have the regression equation y is equal to b0 plus b1 x1 plus b2 x2. So now we have two inputs x1 and x2. We need to compute the value of b1 and b2. Based on that, we try to find what is the value of b0. This is the equation to find out the b1 and the b2. So we have this y is the dependent variable, x is the input variable, and this b0 is the intercept, and b1 and b2 are the slope. And we have given the data. Based on the data, and we need the equation x1 y. So we have to calculate the x1 y and x square, and then x square y, x1 x2, and then x1 square, x2 square and x1 x2. So the values are tabulated here. So we need to first calculate what is our y bar value and what is our x bar value. So after computing the x bar and the y bar, every x value, we need to compute the difference between that x to 1. That is, here your x2. The x2 represent the difference between x2 minus x bar. Okay, x2 bar. So that we have to calculate. Same thing for x1. We need to calculate x1 minus x1 bar. So the difference we need to calculate, and then we have to compute every individual value, take the summation of all. So for this problem we have this. So we have to calculate the summation of y square and then summation of x1 square and x2 square, and then we have to compute the value of y into x1 and then compute the value of y into x2 and then x1 x2. So we just substitute the value x1y. So x1y summation we have this, that is 329,348.57 into x2 square. So x2 square represent here 690.93 subtract sigma x2y. So x2y represent here, that is 39168 into, and x1 x2 is 4744. So that divide by sigma of x1 square. Sigma of x1 square is 450.35.51 the whole square. That is the whole square only it is calculated. So we have to calculate the sigma into sigma x2 square. Sigma x2 square is 690.93. That is subtracted from sigma x1 x2 the whole square. Sigma x1 x2, we have the sigma x1 x2 4744. That should be taken as a square. So while you compute, you will get the value of B1. Like that, we have to calculate the B2 value based on the equation. So we have a B1 value is 4.8479. Like that, we have to calculate the B2 value, and finally we will substitute all the values in the equation. Y bar is equal to B0 plus B1 x1 plus B2 x2. After you compute, you will get the value of B0. We form the regression line and then we will pass the unknown value. So it will try to predict the value of Y predict. And the error between actual and the predicted value should be minimum for getting the efficient regression line. And now we will move to the third algorithm, that is the logistic regression. So logistic regression mainly used to find the or work with the classification problem. So we have the input. So based on that, we have a binary classification. So we have either a class 1 or class 2. So this is also deriving from the linear regression, but the linear regression basically provide the output is minus infinity to plus infinity. But our logical regression is a binary classification which need the output only between 0 to 1. So the line of minus infinity to plus infinity, that is plus minus infinity to plus infinity, now skews between 0 and 1, which is based on the probability. So logistic regression mainly work with the probability. The probability we are passing through a function called as sigmoid function. So this is the formula for the sigmoid function. Sigmoid of x is equal to 1 by 1 plus e power minus x. So as you know, we have y is equal to a0 plus a1x. So now our sigmoid function become 1 divided by 1 plus e power minus a0 plus a1 x1. So now the line is squeezed. So our outputs are restricted in between 0 and 1. Either it will go to 0 class or 1 class. So we have a threshold value. So the probability what we calculated as a sigmoid function, and if it is greater than 0.5, it will be going to the class 1. If it is less than 0.5, it will be going to class 0. So the curve what we get out of the sigmoid function is called as S curve, which represents the logistic regression. And when you compute the logistic regression, the main thing is we have a cost function. So this cost function, we need to make it as minimum. So this is the formula for the cost function, minus 1 by m sigma I is equal to 1 to m y log y predicted value 1 minus y log 1 minus y predicted. So this cost function helps you to provide the output either with the value of 0 and 1. So we have the case 1 when we have the input labels are 0, that is either a class 0. So when we make it 0, the case 1 become 0. So we have only the term for the cost function is the second term, that is minus log 1 minus y predicted value, because this case we have 0 represent. So in the case 1, when y is equal to 0, we have the cost function, the term 2. So when we have y is equal to 1, that is the class label 1, the first term will be retained and the second term becomes 0. So the cost function will retain with the first term. So we get the term 1. So we have the y predicted value. The y predicted value is nothing but the sigmoid of weight, that is our slope, into x plus intercept. So here we are representing here as weight, and this is called as bias. This will be calculated from the given x and y. It will be passed to the sigmoid function, and based on the sigmoid function, we apply the probability as a threshold 0.5. So if it is greater, it will be going to the class 1. If it is less, it is going to class 0. So this is why how the linear regression is now changed as a logistic regression in order to work with the classification problem. So mainly here to adjust the weight, we have something called as gradient descent function. Gradient descent function. So this is our global minima. We want to reach it. Maybe our data point is here and the derivative of the slope is negative. And this is the equation for the weight updation. Weight is equal to old weight minus the learning rate and the derivative value. If the derivative value is negative, so we have this point in the left side. So in order to reach the global minima, the weight has to increase. So the weight has to increase. Suppose in case 2, the data point is here. That is, the derivative is the positive slope. Then the point to reach the global minima, the weight has to decrease. So the weight is decreasing. So this is the formula for weight updation and the bias updation, where we have the old weight minus learning rate and the derivative of the cost function divided by derivative of the weight. And for bias, we have derivative of the cost function divided by derivative of the bias. And how will you calculate this derivative of the cost divided by derivative of the weight? So we have the y predicted value minus y, that will be multiplied with x. And the bias, the derivative of the cost divided by derivative of the bias is y predicted minus y. So mainly the gradient helps to give the direction where to move so that it will minimize the cost function to reach the global minimum. And the selection of the learning rate. If the learning rate is too small, the algorithm will take only small steps to learn and move towards the minimum point. So that will lead to slow convergence. But if the learning rate is too large, the algorithm takes large step and move towards the minimum point easily. But this will cause the overshooting around the minimum point. So this is the data set given to us. And here these are my input variables x1, x2, x3, x4 and x5, x6. And this is my target where the diabetic can be a type 1 or normal, depends upon the features, age, fasting BP, plasma, and plasma F and HB1AC. So here the machine can understand only the numerical data. So the first step, you have to read your data. So after reading the data, we need to divide our input variable separately and the output variable separately. And the next step is we need to do some pre-processing. For example, there may be some missing data. So we need to identify the missing data and you need to replace that missing data with either a mean, median or some imputation methods. You have to use it. And then we have to do the label encoding. So why we need to do the label encoding? Because the machines can understand only the numerical value. Here the target is either type 1 or normal class. The machine can understand only the values. So the type 1 will be moved to class 0 and the normal will be moved to class 1. By label encoding, we convert this categorical value into a equivalent class label, either 0 or 1. And the next step is we need to divide our data into training and testing. So split data into training data set and the testing data set. And the training process using the inputs of X, Y, learning rate, and all those information, we will compute our weight and the bias and the cost function. And during the testing phase, we pass the test data to find the predicted value. And after doing that, so first we have to train the data or train the model, and then we have to test the model. And finally, we need to compute the performance. The performance to compute here is the accuracy. For example, for class 0, I am having 50 data. And then for class 1, I am having 50 data. So after training and testing, I am going to validate. So out of 50 data, my model can able to predict only 40 correctly. And here in class 1, my model can predict only 45 correctly. Out of 50 correct data, my model is predicting only 40 is correct, and here 50 it is calculating 45 is correct. So I need to compute the accuracy. The accuracy formula is how many data is correctly classified for class 0, how many values are correctly classified for class 1 divided by the total data. So I have totally 85 by 100. So the accuracy of my model is 85%. So this is the way you can compute the performance of the classification algorithm. And this Python code helps you to do this particular logistic regression. So we need to initialize the learning rate and how many number of iteration it has to follow to train the model. So iteration and the learning rate are given. So we want to train our model. So to train our model, we have to pass the training data and the testing data and the learning rate and the number of iteration. When it comes to the model, the input X, that is X contain your input data. So for that we are calculating how many rows available, how many columns available. So based on the column, our weight matrix got initialized. That is based on the number of input features, the weight matrix get initialized. So after initializing the weight matrix, we need to initialize the bias value. And we have to calculate the cost, and this cost will be stored in an array so that we can able to plot every iteration how the cost get minimized. And by using the for loop, we have to use the number of iteration, and for every input, this is actually our input Wx plus B. So for that we need to pass the or compute the sigmoid function, which is nothing but 1 divided by 1 plus e power minus Wx plus B. So this is actually our sigmoid function. And based on the sigmoid function, we have to compute the cost function. The 1 by m into y into np log a plus 1 minus y into np dot log 1 minus a. Next, we need to calculate the derivative of weight and the derivative of bias using the formula. Once it is computed, next we have to do the weight updation. So the formula for weight updation is new weight is equal to old weight minus learning rate into the derivative. Like that, we have to update the bias value also. And every iteration, the cast will be stored in the cast array. At the end, we are passing or we are returning the weight, bias and the cast value. So by using this, I am going to plot for every iteration. Okay. So every iteration, what is the cast value? So initially the cast value is high. When the algorithm goes off, the cast value try to reduce it. So this we need to plot it. And after developing the model, we need to predict. So during prediction, we need to pass the test data so that we get the Y predicted value. And the performance will be analyzed using the accuracy. So when you calculate the accuracy, so we have a how many number of Y test, that is the actual value correctly classified, and the predicted value correctly classified with the same label is 0 or 1. So we have to compute that, and the correctly classified divide by the total instance, that will be multiplied with 100, we get the percentage of accuracy. And while we predict, okay, so while we predict, every test value you pass, it will again compute the Y predicted value, that is equal to 1 by 1 plus e power minus the weight you computed from the training model, and then your X test value, and the bias also we computed based on our model. So this value you compute. This predicted value, you will get a probability between 0 to 1. So now we decide whether it will go to class 0 or class 1. We are having, based on the sigmoid output, we are computing the threshold, whether it is going above 0.5 means it is 1 class or it is 0 class. So like that, every X test value, we are getting the predicted value. So that only we are trying to find how many predicted values you got correctly as our test value, and based on that we are computing the accuracy. So this video helps you to work with simple linear regression, multiple linear regression, and last with the logistic regression, which is mainly used for the classification purpose. Thank you.